Hello everybody, and welcome to our next video on reviewing trig functions. Today we're going to look at chapter 10 in your book, and we're going to start by reviewing the general sine function. So in our sine function, we have different values here that will tell us about the shape of our graph. So first, the a part of our equation tells us about the amplitude of our function. Amplitude represents the distance that our function goes from its axis, its central point. So how far up or how far down the wave goes from its axis. Let's take a look at D for a second. D represents the vertical translation. So how far up and down are all of the points shifting, the entire graph? The B value represents the period of the function. So the period is how long it takes to do one cycle, one full shape. For a sine function, it has an up part and a down part. Okay, and the C part affects the horizontal translation. So how far are points shifting left or right? The entire graph, all the points. Now notice I put wacky brackets up here. That's because the signs of A and D are pretty obvious. If A is positive, then it's representing a function flipped, or function in the normal orientation. If it's negative, it has been rotated or flipped through the x-axis. And D, if D is positive, we move up D units. If D is negative, we move down D units with all of our points. But B and C are opposite to what we think because they're in the wacky brackets. So for C, even though it looks like it's negative and we should move to the left, if this value is negative here, it actually means we should shift to the right. And for B, if B looks like a large value, it means that the function's actually getting vertically compressed, which means more cycles happen at the same time, in the same space. The principal axis of the general sine function is y equals d. So d tells us where this axis is, that line that cuts my wave in half horizontally. The period is always 2 pi over b. So for a sine function, it normally takes 2 pi radians to make a full rotation, but b will determine how many rotations it takes. And the amplitude is always a positive, it's always an absolute value because it's representing a distance from an axis. So for example, if we were just looking at these equations, what could it tell us about the shape of the function? And also this sign here is a placeholder. These different parameters, A, B, C, and D, hold for any trig function, sine, cosine, tangent, okay, and their reciprocal identities. So everything we've said about transformations can apply. So for example, here, this function, it has an A value of -3. That means the amplitude is 3. It has a B value of 1/4 because it's 1/4 times the x. So the period is 2 pi divided by 1/4, or 8 pi. And it has a D value of 1, which means all of the points are shifted up 1 unit. Okay, the axis is shifted up 1 unit. Now for a sine function, the domain is always x belongs to real, all real numbers. But our range is normally between 1 and -1. Because the amplitude is 3, it stretches up to 3 and down to -3. But then because we shifted everything up, now the highest value for y is 4 and the lowest value for y is -2. The tan function is a little different. We'll take a look at that one last. For the cosine function here, the 3 represents the amplitude. The pi in front of the x is the b value. So when I go to calculate the period, I do 2 pi over pi, which just gives me 2. And the domain is x belongs to real. The range is, it has a maximum height of 3 and a minimum height of -3. For tan, the tan function looks a little different. So we'll return to this after we've taken a look at the tan graph. Thank you, and continue to the next video, please.